Hi, and welcome to Lesson 3.1, Identify Pairs of Lines and Angles. So this is our first lesson in Chapter 3. Chapter 3 focuses all on parallel and perpendicular lines, and obviously the angles that create parallel and perpendicular lines. So we need to begin with a few different definitions. So the first definition we're looking at is that of parallel lines. And parallel lines are two lines that are coplanar, so on the same plane, and do not intersect. So they will never intersect and they exist on the same plane. Skew lines are two lines that are not coplanar and do not intersect. So skew lines are not on the same plane and do not intersect. And then we have parallel planes, which are two planes that do not intersect. So example 1 here says, think of each segment in the diagram as part of a line. So for example, X to W is a segment that would be part of line XW going on forever. Or same with XY. So complete this statement with parallel, skew, or perpendicular. Now, we did not have perpendicular up here, but perpendicular lines are lines that meet at 90 degrees or a right angle. So if they meet at 90 degrees or a right angle, they are perpendicular. And then we also can have perpendicular planes, which are planes that intersect at 90 degrees or right angles. So up here we had parallel lines, skew lines, parallel planes. Then we also have perpendicular lines, which are lines that intersect at 90 degrees, and perpendicular planes, which are planes that intersect at 90 degrees. So example 1, part A, line WZ and line XY are blank. So WZ right here, and then XY back here. Well, they make up the two sides of that rectangle on top, so they're on the same plane, and if we extend them forever, they'd never intersect, so they are parallel. Line WZ and line QW are perpendicular. So WZ right here on the front, QW running right here, they meet at 90 degrees in this corner, so they would be perpendicular. And we are assuming that this is a rectangular prism, meaning all the angles in the corners are right angles, and all the sides are congruent to their opposite side. So then we have part C. Line SY and line WX are skew. So SY over here and WX over here are on different planes and they do not intersect, so they are skew. Plane WQR, so WQR, which would be WQRZ, this whole front, and plane SYT, so SYT, so SYT and X is the plane on the back. So the plane on the front and the plane on the back are parallel. And then plane RQT and plane WQR are perpendicular. RQT, the bottom, WQR, the front, and the front and the bottom intersect at 90 degrees, so they would be perpendicular. Then in example 2, use the diagram from example 1 which lines or planes appear to fit the description. So we're saying that they appear to be parallel in part A. So lines that appear to be parallel to, and it should be not AB, but QT. So lines that appear to be parallel to QT. What would be parallel to QT would be SR on the same plane, WX on this plane, and ZY, because even though they don't draw it in, there would be a plane that runs a diagonal from QT to ZY. Then lines perpendicular to ZR. So ZR being this one here on the front, anything that meets it at 90 degrees. So we would have ZY, SR, WZ, and QR. Then for part C, lines skew to YX and containing point Q. So YX being up on the back here, skew to that, containing point Q, we would have TQ, and we would have QW. Then we move to point D. D says planes perpendicular to plane WZQ. So plane XYZ, plane TQR, and plane YZR are all perpendicular to WZQ, or the front. So they all intersect that front at 90 degrees. And then part E, planes parallel to WZY. And we only have one of those, which would be plane QRS. So QRS, the bottom, would be parallel to WZY, the plane on top. Then we get to our two postulates, postulate 13 and 14. Postulate 13 is the parallel postulate, which states if there is a line and a point not on that line, then there's exactly one line through that point parallel to that given original line. So if a line already exists and there is one point not on that line, there is one line that could be drawn through that point parallel to the original line. And then our perpendicular postulate, which says if there's a line and a point on the, or not on the line, then there is exactly one line through the point perpendicular to the given line. So that should say exactly one line, not on line. So if there's a line, point not on the line, there's only one line that can be drawn through that point perpendicular to the other line. And then we move into this idea of a transversal. Transversal is a line that intersects two or more coplanar lines at different points. So if we look at the diagram over here, we have these two lines, and the transversal would be this line right here. It cuts the other two lines or intersects them at different points. And when two lines are cut by a transversal, we create several different kinds of special angles. And these angles you're going to use quite a bit in future proofs, so you want to become familiar with the different types of angles here. So when dealing with a transversal cutting any two lines, we create these four main types of special angle pairs. So the first type would be corresponding angles, which are two angles that are in a corresponding position along the transversal. So in this case, the transversal here What's in the upper left where it intersects this line is 5, and in the corresponding point, the upper left of where it intersects the other line, is angle 1. So then another corresponding angle would be angle 2 in the upper right of that intersection with the transversal, and angle 6. Angle 7 down here in the bottom left would correspond with 3, and 8 would correspond with 4. Then we have alternate interior angles. So the interior is the space in between the two lines being cut by the transversal. So our interior angles would be 3 and 4, 5 and 6. So whichever ones are in between the two lines cut by the transversal. Then the exterior would be made up of angles 1 and 2, and 7 and 8. So alternate interior angles are two angles that are on opposite sides of the transversal on the interior. So angle 3 and angle 6, and angle 4 and angle 5 are alternate interior angles. And then we have alternate exterior angles. So they are on the alternating sides or opposite sides of the transversal on the exterior. So angle 2 and angle 7 would be alternate exterior angles, as well as angle 8 and angle 1. And then the final type we're going to look at right now are consecutive interior angles. And consecutive interior angles are on the same side of the transversal in the interior. So angle 3 and angle 5, as well as angle 4 and angle 6. So then we're going to classify each pair of the angles in this diagram using those definitions above of corresponding angles, alternate interior, alternate exterior, or consecutive interior. So in part A, angle 3 and angle 9. So in this case, 3 and 9 are along this transversal. These are the two lines being intersected. So 3 and 9 are on the interior, alternate sides, so they're alternate interior angles. 5 and 13. 5 is here, 13's down here. So I'm dealing with this as my transversal. These are the two lines being intersected. 5's in the upper left, 13's in the upper left, so they are corresponding angles. C, 4 and 10. 4 is here, 10 is down here. So again, we're dealing with this transversal. They're both on the interior on alternate sides, so they're alternate interior angles. Then we get to D, 5 and 15. 5 is here, 15 down here, so dealing with this transversal. Both are on the exterior, opposite sides, so they're alternate exterior angles. 7 and 14, both over here, dealing with this transversal on the interior same side, so they're consecutive interior angles. And then in F, 1 and 11, along this transversal, they are on opposite sides of the exterior, so alternate exterior angles. And then, as you can see at the bottom, there's the practice problems for this lesson. But to begin with, you want to make sure you're familiar with these 4 definitions for these angle pairs, as well as familiarizing yourself with the transversal and the idea of parallel lines, skew lines, parallel planes, and then perpendicular lines and planes.